Good day, student. You are welcome to my channel, Technical Drawing Made Easy, where we solve complex technical drawing questions and make it simplified and make your learning easy. Today we'll be looking at Waec 2022 Technical Drawing Paper 1, which is always the objective test. You will be given 40 questions for 40 marks, and you will be given a duration of 1 hour to answer the questions. You'll be given option A to D. You have to pick the best option that is suitable to the question. So take note of this. If you are joining my channel for the first time, please like, share, and click the notification button to get more solutions coming your way. I appreciate you for watching the video, for putting effort into your learning. So we start from section A. Section A is always 30 questions. It is focused on the geometrical aspect of technical drawing. So we'll be looking at questions on geometric aspect of the drawing. So building and mechanical drawing will take 10 questions. That is optional. So we get to the section B aspect. So this section A says answers all the questions in this section. So question number 1. Question number 1 says 100 millimeters square is the same as dash. 100 millimeters square is the same as dash. You have to take your time to do this. This is the mathematical aspect of technical drawing. So we start with 100 millimeter square. For us to solve this question, this is an area scale. So we need to convert it to a linear scale. Look at the conversion. First, we split 100 into 2 in tens. So if I want to split 100 in tens, that will give me 10 times 10 will give me 100. Then if I'm to split the millimeter square, that will be millimeter times millimeter. My option is given in centimeter, so I have to convert to centimeter. I have to convert to centimeter. So you ask yourself, what is the relationship between millimeters and centimeter? We are told that we are given as 10 millimeter is equal to 1 centimeter. 10 millimeter is equal to 1 centimeter. That will give us 10 millimeter will be 1 centimeter times 10 millimeter will be what? 1 centimeter. So if you multiply this together, 1 times 1 will give us what? 1 centimeter times centimeter will give us centimeter square. So the answer to this question is option A. Option A. Number 2. A certain line is parallel to the horizontal plane. Remember the word parallel to the horizontal plane, but inclined to the vertical plane. But inclined to the vertical plane. That means if we have a plane like this, which is vertical, and another plane, this is VP, another plane which goes like this, which is what? Which is horizontal. And we have, for example, a line which is what? Which is parallel like this. So this line is parallel to the horizontal plane, but at an inclination to the vertical plane. Which of the following views shows the true length of the line? That means since it is parallel to the horizontal plane, since that line is parallel to the horizontal plane, if you project this, it will fall at this angle, to be at an angle. Can you see it now? To be at an angle to the vertical plane. But this line is going to be parallel to the horizontal plane. So in what view can this show the true length of the line? It is only at, when you are looking at it from the top, you are going to see the true shape of the line. When you are looking at it from the top, you will see the true shape of the line. So the answer to this question is the plan. It is when you look at it from the top to get it that you will get this length. So we'll go to question 3. Go to question 3. We have this, the length L. This is where L is. This is L written here. So they are talking about the depth of this block. They are talking about the depth of the block. That is the depth. The length L in figure 1 is half full length. That means when it is being drawn, it is drawn at half full length. Half full length. Half full length. Take note of that. Let's go look at the question. What type of pictorial view is shown in the sketch? What type of pictorial view is shown in the sketch? When we draw the depth of an oblique projection, when we draw the, let me put it this way, when we draw the depth of an oblique projection to half length, to half full length, the drawing is referred to as cabinet oblique drawing. Cabinet oblique drawing. So the answer is A, cabinet oblique view. That this is half full length. You can also be asked about cavalier. Cavalier is when we draw it at what? At the full length. So when it is drawn at the full length, when the depth is drawn at the full length, it is cavalier oblique view. Perspective drawing is another type of pictorial drawing, which is a three-dimensional drawing. Also isometric drawing, I believe you know those two types. Number 4, the locus of a point which moves round a right cylinder axially at a uniform speed is dash. Let me take that again. The locus of a point which moves round a right cylinder. That means when we have a cylinder like this, remember a cylinder is a three-dimensional shape, and we have a point that moves round the cylinder like that. It moves around the cylinder like this. It moves around it like that. So when a point moves round a cylinder axially, that means along the axis at a uniform speed, the locus that will be formed is referred to as helix. It's referred to as helix. So it's a three-dimensional curve. It's a three-dimensional curve. I believe we'll see more of this curve as we go on. So this is a three-dimensional curve. A cycloid is a two-dimensional curve. An involute is a two-dimensional curve. This is two-dimensional. This is two-dimensional. This is two-dimensional. So helix is a three-dimensional curve. So the moment you hear the word cylinder, which is a three-dimensional shape or object, it's going to be ellipse. So just use all these clues to answer the question. Let's go to number 5. A length of 1 meter on land is represented by 2 millimeters on a drawing. What is the drawing scale used? What is the drawing scale used? If you have been watching my channel, you'll have seen me giving the simple formula for finding scale. Formula for finding scale is simply scale is equal to the size of the drawing D all over the size of the object O. The size of the drawing D over the size of the object O. So in this place, what is the measurement on the drawing? We are given what? Look at it. By 2 centimeters on the drawing. That is 2 mm on the drawing. All over. What is the size of the object in real life? They said 1 millimeter on land. That means in real life, the size is 1 meter. So to get the scale, we need to convert. The two of them should be in the same unit. So you can convert them to both meters or convert them to both millimeters, depending on the one that is easier for you. But the easiest is just to convert it to millimeters, since millimeter is the smaller dimension. So to convert millimeters to meters, how many millimeters will give us 1 meter? We have 1,000 millimeter to give us 1 meter. 1,000 millimeter to give us 1 meter. Take note. So we have 1,000 millimeter. So mathematics now. Millimeter will cancel out millimeter, please. Then 2 in 2, we have 1. 2 in 10, 5. In 0 here, 0. In 0 here is 0. So you can see what we are left with. Our scale will be what? 1 ratio 5. 500. Our scale will be 1 ratio 500. So the answer here will be what? Will be D. Take your time. Whenever you are given a mathematical question in technical drawing, you take a little time to solve it. Good. This question number 6 says the sectional view on plane PP. This is where the plane is. The plane goes through from here. You see it, and comes out here. And we are looking in this direction. The arrow tells you where you are looking. So you are looking at it from this part. You are looking at it from this part. So you can see the arrow, where the arrow is pointing to. So we have to look at it. So the sectional view on plane PP of the block shown in figure 2 is, this is a full sectioning. It's cut entirely through the object. So how do we know the part that is cut? Just take note of the part of the object that is cut. And take note, only the part that the material of the object is that we section. For example, look at this place. The material falls on this side. So we have this. You see that? Good. This part is a hole. Can you see it now? So that means when we are looking at this place, it will not be sectioned. That is why this place is not sectioned. You see now, this place is not sectioned. That point is not sectioned. So this part is not sectioned. So because of the O, and this line in between that space represents the center line that you are seeing at this point. Then the line, the cut still extend down. Do you see that now? It extends down. Then it continues along this part like this. Do you see it now? So it cuts that. And if you noticed, this part, let me see the part I'm shading. Yes, that part is not being cut. So when you are looking at it, you will notice that that part has a space that is not hashed. So that part is not hashed, and you'll be seeing it when you look at it from the angle, this arrow that I drew here. Do you get it now? So A is the what? Is the answer. If you look at B, B will not be the answer. Why? Look at this part. They did not section this part correctly. Do you see that now? This one will not be the answer because they sectioned all through. It will not be the answer because C will not be the answer because they sectioned all through. Then D will not be the answer because they also sectioned all through. So we know the reason why we are picking option A. So if you are asked in other upcoming questions, you will understand how to pick the right answer. So we'll go to question 7. Which of the following conic sections has an eccentricity of less than 1? Which of the following conic sections has an eccentricity less than 1? The answer here, before I give you the answer, let's look at the eccentricity. Eccentricity is talking about the distance from the focus to the eccentricity and the distance from the vertex to the eccentricity. So eccentricity is represented by small letter e. So for hyperbola, it is always eccentricity is always greater than 1 for hyperbola. For parabola, it's always what? Equal to 1. And most times in drawing, we refer to 1 as unity. So in questions, when they tell you the eccentricity is unity, the unity is eccentricity is unity. So you know that they are also referring to when it is 1, that is parabola. Ellipse is when the eccentricity is what? Is less than 1, less than unity. And eccentricity for circle is when it is equal to 0. So take note of this in case you are asked another question. For hyperbola is greater than 1, for parabola is equal to 1, for ellipse is less than 1, and for circle it is equal to 0. And 1 is also referred to as the word unity. So the answer here is what? Ellipse. Let's go on. 8. A trace is the intersection of two dash. A trace is the intersection of two dash. When we have a line from a plane, maybe the two principal planes, vertical and horizontal, and the line is being projected into another plane. So it is intersecting another plane. When a line is intersecting a plane, a trace is formed. Also, we also have a trace of planes. When two planes are, a line is coming from two planes and they are intersecting each other, we call this also a trace. So it could be a line intersecting a plane or two planes intersecting each other. So when a trace is the intersection of two planes in this place. So the answer is B, planes. Go to number 9 now. You're asked to use this. The sketch in figure 3 shows a method of dividing a line into a desired number of parts. The sketch in figure 3 shows a method of dividing a line into a desired number of parts. Use it to answer questions 9 and 10. So let's look at this question. The ratio by which line PT is divided is, this is line PT here, this is P, this is T, that is the line drawn. So they want us to find the ratio by which it is divided. So let's count. First, you have to count to know the division. We have 1 here, we have 2. The second division is 1, 2, 3, 4. The third division is 1, 2. So let's write out the ratio. The ratio is ratio 2, ratio 4, ratio 2. Good. But if you look at the options, they're not giving you something like this. Simple math. So they simplify to the smallest ratio. They just simplify the ratio. So what can go in all these numbers? Where 2 can go. So if you say 2 in 2, we have 1. Ratio 2 in 4 is 2. 2 in 2 is another 1. So if you have this, what's the answer? We have D. So you can see, just simplify that and you get your answer. Number 10. Number 10 asks us if the actual length of the first 3 portions of line PT is 4 centimeters. What is the length of PT? Even before looking at the option, we can do this ourselves. They are asking us for the entire length of PT. If the first of the 3 portions, that means this is the first portion here, from this point down to this point. That's the first portion of the 3. They tell us if that is 4 centimeters. Can you see it now? And what is the entire length of PT? So you just have to find one portion there. Since the first portion is 1, 1, and 2. Can you see that now? So just divide 4 centimeters by 2 to get one part. So one part will be what? 2 centimeters. So if this one part, look at it here, if this one part is 2 centimeters, so we just, is multiples of 2. So if we have multiples of 2, we have 2 here, 4, 6, 8. The next one will be what? 10, you are right. The next one, 12. Can you find the next one? 14, and the last one be what? 16. And from the unit you are given to be what? 16 centimeters. So without even looking at the options, you should be able to calculate that yourself. So let's look at the options if the answer is there. So you can see the answer is 16 centimeters, which is option C. Question 11. A quadrilateral with 4 equal sides. 4 equal sides. Take note. Whose diagonals intercept each other at right angles is, I've told you once, right angle stands for what? 90 degree. 4 equal sides. That means it's going to be a quadrilateral. Good. Then they're asking us which of these. Is it a rhombus? The rhombus looks this way. Remember, all sides of a rhombus are equal. Good. Is a rhombus. All the 4 sides are equal. A rectangle looks this way. Can you see? Opposite sides are equal. But not all 4 sides are equal. So it's not a rectangle. A deltoid. Before I go to deltoid, let's go to kite. A kite looks this way. A kite looks this way. This side is equal to this side. This side is equal to this side. This is a kite. But all 4 sides are not equal. Can you see that? Now let's come back to deltoid. A deltoid is an inverted kite. Can you see it? This side is equal to this side. Then this side is equal to this side. This is what we call a deltoid. You might not have seen this shape before. That's what is called a deltoid. All the sides are not equal to this side. So the first thing you notice is rhombus has all the sides to be equal. And also, if you join the diagonals together like this, can you see it now? Opposite vertex. You join them together like this. At this point, 90 degree will be formed. A right angle will be formed. So from the question we are asked, this is the shape that obeys that question. So a rhombus A is the answer. So we'll go to question 12. A regular solid that is bounded by 4 equal triangles. Good. A regular solid that is bounded by 4 equal, take note of that, 4 equal triangles. So when we have equal triangles forming a shape, we call them a hedron. We call them a hedron. So depending on the number of equal triangles that we have, that is what will determine the type of shape we are asking. So for this question, when we have 4, please take note, 4 is tetra. This is now, so the answer is A. I'll analyze others. When we have octa, that is 8. From the, you remember your octagon, right? Good. Octa. When we have dodecahedron, remember your dodecagon. Good. Dodeca is what? Is 12. Icosahedron. How many people know icosagon? How many people know icosagon? Go and find out. That is 20. That is 20. Do you get that now? Icosagon is 20. So we have icohedron. That will be. Now let me show you what they mean by equal triangles. So when we have a triangle like this, equilateral triangle, this is the base. So we're going to put another equilateral triangle on top. This is also going to come here. Do you see it now? So this part, the back I first drew, that is 1. This part for this is 2. This one for this is 3. And the base is what? Is 4. So when the shape is like this shape is actually also what we call a triangular what? Triangular prism. Go and look at a triangular prism. and we have a triangular prism. So we have a triangular prism, that is the shape that will be formed. Let's go to number 13. The sketch in figure 4 shows a method of dash. Look at the sketch you are given. Let me clean on this side. Okay, look at the sketch you are given. So we have a triangle there. And let's read through the option. A is circumscribing a triangle. No. When you are circumscribing a triangle, the sides are to be bisected. In this place, they are not bisecting 2 or 3 sides. They only bisected one side. Also, locating the center of a triangle. No, they are not trying to locate the center of a triangle. If they are trying to locate the center of a triangle, they should be bisecting the what? They should be bisecting the angles. Dividing a triangle into 3 equal parts. No, that's not what is happening. Dividing a triangle into 2 equal parts. The answer is what? The answer is D. They are dividing a triangle into 2 equal parts. So this is the method for dividing a triangle into 2 equal parts. If you don't understand that, check out that aspect in my videos in this channel. Number 14. Which of the following views represent the locus of a point equidistant? Equidistant here means what? It means equal. Equidistant means equal distance from the circumference of 2 unequal circles. If you look at this circle with center 0, 1, and this circle with center 0, 2. Do you get it now? So there are 2 unequal circles, and you are asked to draw a locus having equal distance from their circumference. From the circumference. When you are drawing this, the shape is going to be formed like this. Can you see that? That's how the shape will be formed, to be backing the bigger circle. So the answer is what? The answer is option B. The answer is option B. Go and try constructing that and see the shape that will be formed, the curve that will be formed. Number 15. Triangles on the same base and between parallel lines. If triangles are on the same base, look at this. These are parallel lines. Having equal distance between them means they will be having equal height. Do you see that? And if they are sharing the same base, can you see? The same base. So if I draw a triangle like this, and I draw another one like this, can you see that now? Let's say this is triangle A, B, C, and this is triangle A, B, D. What will they have equally? What will they have equally? They will have this equal area. So take note, the area of a triangle is equals to half base times height. So in this place, they share the same base, B, and they share the same height, H. So they will be having the same height. They will be having the same height. They might not share the same altitude. They might not share the same length. They might not share the same directories. But we are sure that they will be sharing, they will be having equal area from this question. Number 16. Which of the following plane figures is not a parallelogram? Which of these following plane figures is not a parallelogram? So take note. First, ask yourself, what is the quality of what is the property of a parallelogram? What is the property of a parallelogram? A parallelogram must have equal opposite sides, 1, and equal parallel sides. Do we understand that? the opposite side should be equal and parallel. That means this side I labeled A should be parallel to this side B I labeled, and they should also be parallel. Then side C should be equal to side D, and they should also be parallel to each other. So let's look at it one by one. A, this side using this sign, you see those two dash means they are equal, and this sign 1 1 shows they are equal. And also they are telling you that you can see the sides, they are parallel to each other. Same thing for B. If you look at B, this arrow shows that this side is parallel to this side. This side is parallel to this side. And this side is equal to this side. That's what they are showing you. Also, if you look at D, this sign means it's equal to this side. This sign means this side is equal to this side. And this arrow shows they are parallel to each other. When you see arrows, the same arrows on the lines, it means they are parallel to each other. But if you look at C, C is not a parallelogram, it's a trapezium. Trapezium is a quadrilateral, that means a four-sided shape, having only one opposite side to be parallel. Having only one opposite side to be parallel. Even the opposite sides are not equal to each other. You can see the side. This is longer than this. Do you get it now? But they are parallel to each other, shown by this arrow. And this side is not parallel to this side. Can you see that now? So the answer to that question is C. Question 17. When the curved surface of a hollow cone, the curved surface of a hollow cone, look at a cone. This is the shape of a cone. Can you see that? A cone. Hollow means there is hole inside, there is space inside, it's not covered, it's not closed. So when we cut it open, what does it form? It is what I've just drawn. It's going to form the sector of a circle. It's going to form the sector. Please don't be tempted to write a regular triangle like this. No, we'll only have a triangle like this when we are drawing the front elevation of the cone. But when we are talking about the surface, curved surface area of a hollow cone, when it is cut open, exactly what we can find in question 18. Can you see that shape? Yes, this shape is the sector of a circle. B is not the answer. This is a segment. Let me show you. If this part now, let me show you. This part, if I pick this part like this, can you see a chord and an arc? And this part is the segment. So I'm doing this to explain so that when you are asking other questions, they might be asking you about segment. Do you understand? So you understand what a segment is, because some students do not understand segment. So this part I showed it now is the segment, while the entire thing is the sector. Then semicircular cubical parabola. That's talking about parabola. That's a special curve. So let's move on. So question 18. Remember, this is the surface development of a what? Of a cone. Then they are now asking you, the sketch in figure 6 shows the surface development of a truncated what? Dash. Just like what I've explained here. That's surface development of a cone. So your knowledge of 16 will give you the knowledge of 17. It is easy as that. So number 19 now. Figure 7 shows an external tangent of arc R 100 to 2 equal circles. Good. Let me read it again. Figure 7 shows external tangent. That external tangent is from point P here to point T here. Do you see that now? And the arc is what? R100. This is it here. Good. So the distance there is the radius of that arc is 100. to 2 unequal circles. Good. So the biggest circle is on the left and the diameter is 80. So how do you answer this? Let me explain so that you understand. Look at the line I'm drawing. Just look at the line I'm drawing. This is the diameter. Can you see it? Of this triangle. So if that's the diameter, and the diameter is given as 80, so let's split it into radius. This side will be what? 40, and this side will be what? 40. Excellent. I'm splitting it for you to understand. So they are now asking me that what is the length R1. So, and let me extend it again from the center here down here to this point is what? Is R1. So take note, if from this center here, can you see the point? Good. To this point, look at what I'm drawing, is 100. Do you get it now? And from here to here is 100. That means from here to here is what? 100. So what will be from here to here? Can you see that now? From here to here is 40. From here to here is 40. Do you get it now? Then from the entire line is 100. So what will be from this point to this point? That will be what? That will be 60. Look at it here. So 100 minus the 40. Let's do the same for the smaller circle. Look at it. Smaller circle says it is what? It is 30. So let's split it. 15 and 15 on the other side. So if from here to this point is 100, entire of everything is 100. So take away from the center here is what? To this point is R2. So take away 15 from 100. That is what? 85. So the answer to that will be what? Will be B. That's how to answer that question. So just take away the 100 from each radius of the circles and you have your answer. So the values of R1 and R2 are respectively 60 and 85. Question 20. The axial distance for one revolution of a two-start screw thread. Two-start screw thread is the what? Is the lead. Axial distance. That means the distance between the threads. So is the lead. So that's the answer to that. Let's go to question 21. Let's go to question 21. The sketch in figure 8 shows a diagonal scale of 1:100. Use it to answer question 21 and 22. So we are given this diagonal scale. So you take your time to study the scale. Then I ask us, what is the value of M on the scale? Look at where M is indicated. So how do you calculate this? First, you are going to read the main scale. The main scale is at this place. Look at what I'm showing you. This point is 0. That shouldn't be 2 written there. That shouldn't be 2 written there. That should be 0, please. That should be 0, not 2. I believe it's a mistake from the from Waec when they were setting the question. This point is 0. Do you get it now? Maybe they wanted to put it at the next point after it. So do you get it now? So you first read the main scale. The main scale goes to the right, while the subscale goes to the what? To the left. We have two subscale for diagonal scale. So for the main scale, let's read. We have 1 and 2. Can you see it now? At this point, 2. So your main scale is what? Is 2 meters. Can you see that now? Good. 2 meters. Then for your subscale, remember I told you we have the subscale. So you are going to calculate the horizontal subscale first. You are going to find the horizontal subscale. And when you are reading the horizontal subscale, you read at 0 point decimal. Do you get it now? So because it's a lower scale. So let's count that point. We have 1, 2, 3, 4, 5, 6. Even for me, I like counting from on the line. I have 1. This is 0.0. Remember, 1, 2, 3, 4, 5, 6. Let me count it well. Okay. This is 1, 2, 3, 4, 5, 6. Good. So that is 6. So this point is 6. So that is 0.6. Do you get it now? Then the vertical subscale will be at 0.02 decimal. Can you see that now? So that will be what? Let's count. 1, 2, 3, 4, 5, 6, 7. Can you see that now? So it is on that point 7. Do you see that now? So if I add everything together, I'll be having what? 2.67 meters. Can you see that now? So the answer is what? Is B. You must learn how to read scales, especially diagonal scale. It is very simple. Read the main scale to the right first, then read the horizontal scale to the left, then you read the vertical scale to the left. And remember to add the decimals because they are lower than each other. The next question says, the actual length of the object whose length is measured in m on the scale is dash. Can you see it now? We have the length of our main scale to be 2.67. Then they are asking us the actual length of the object. Remember when I was talking about scale? The size of the drawing and the size of the object. So here they are asking us the actual length of the object in real life. So how do we do that? Good. We are given the scale here. We are going to go back to the question. We are given the scale here. They tell us it is what? 1:100. So if the drawing is what? Is 1. And in real life it is 100. So what will be the size of the drawing in real life? That is what they are asking us. So it's just for you to multiply that drawing by 100. You have to multiply the drawing by 100. So you multiply 2.67 by 100. When you do that, you just take 1, 2. Remember your multiplication of decimal in primary school. So we have 267 meters. It's as simple as that. So the answer to this is what? Is C. 23. The sketch in figure 9 shows a circle. The sketch in figure 9 shows a circle with chords. The chords are MN and NP. A chord is a line touching the circumference of a circle at 2 points. It shouldn't pass through the center. If it passes through the center, it's no more a chord. It is now referred to as a diameter. Symmetrical about the axis. Symmetrical about the axis means both sides are identical. They look exactly the same. So the axis they are talking about, when we say axis in technical drawing, is the center. Do you get it now? They are symmetrical about the axis. So the center NR and MP, they are symmetrical. If you look at up and down, left and right, they are identical. The axis MQ and NR. Can you see what I'm talking about? Good. So use it to answer question 23 and 24. 23 says the value of angle NPQ. NPQ. You are given the arrow there. Look at this. I told you the angle is formed at the letter in the middle. That is P. So this point is what they're asking us to find the angle. So they're asking us to find the value of that angle. So take note. When we have a triangle position at the semicircle of a circle, semicircle, when we have a triangle position at the semicircle, do you get it now? This place is going to be 90 degrees. So if this place is 90 degrees, tell me what this place will be. This place will be 45. This place will also be what? 45 degrees. Also, since they are symmetrical, I can even connect this and connect this. This will also be what? 90. This place will be what? 45. This place will be what? 45. Take note of all this. It's very simple. And also, this method, in technical drawing, we use it for drawing a rhombus in a circle. We use it for drawing a rhombus. And remember what we talked about a rhombus earlier on, that they have equal sides. And the center angle, the right angle is formed at the center. So they're asking us to find the angle NPQ. So if this, remember this is a straight line. Do you get it now? If this part is what? Is 45. What will be this part? This is what we refer to as supplementary angle. Angle formed, two angles formed on 180, a straight line. So if this place is 45, that means this place will be what? 135 degrees. Very simple. Just take away 180 from 45 degree. So we have 135 degree. It's as simple as that. I believe you all understand this. You all understand this. 135. So the answer is what? Is C. Then we'll go to question 424. The value of angle, let's look at that angle. The value of angle NMP. Where is the angle formed? I told you the one in the middle, M. So let's look at M. NMP. Good. This place. That's what they're asking us. And I've talked about that before. Can you see that now? So if this place is 90, this place will be 45. This place will be what? 45. I explained that before. So the answer here is what? Is D, angle 45. We move on to the next question. Excellent. The sketch in figure 10 shows a curve propagated by rolling a cylindrical surface. I've answered this. I've talked about this in this class, in this video. I've talked about this. When we said a rolling cylindrical surface is what? Is it 2D or 3D? I've talked about this. A cylinder is a what? Is a 3D shape. So when it is rolling, it's going to form a what? A three-dimensional what? Three-dimensional curve. So you don't, even without looking at the drawing, you should be able to answer this question. They said the curved T formed is what? Is ellipse. Let me go back for you to see that we have answered this question before. This question, we're in question 25. So let me go back and see the questions we have answered when we talk about a 3D curve. Good. Let's go back. Let's go back. No, I've answered this question earlier on. Sure, I've answered the question earlier on. Let me see. What talking about? Good. Can you see it now? Look at question number 4. It's still there. The locus of a point which moves around a cylinder axially at a uniform speed is what? Is an ellipse. Can you see? They asked this question twice in different ways. So that's what I'm talking about. So when you understand this, you don't have any problem. When you understand this, you shouldn't have any problem. So when they are talking about a cylindrical surface, a three-dimensional surface, a curve is moving around it. That is going to form a 3D curve, and that's going to be an ellipse. And a parabola is a 2D curve formed on a conic section. An involute is a 2D curve formed in the shape. A cycloid is a 2D curve of a point on a circle rolling on a straight path. So please take note. They asked this question twice. There is no even need for bringing up this drawing for question 25, but I think it's because of 26 they brought up the drawing. The length marked G. Can you see the length? Good. The length marked G is the what? Is the circumference, because the cylindrical curve is rolling. So when we are measuring it, we have to measure it along the circumference. The circumference, because the cylinder has a circle at the bottom, and that is the part that is using to roll. So this distance is to be the circumference. Do you get it now? So we'll move to question 27. Oh, This question is on equal areas of similar figures. Equal areas of similar figures. So let's look at the question. Figure 11. In figure 11, the polygon, let's mark T, V, can you see that? W, okay, X, Y, that is the shape we are given. That's the polygon. Is equal in area to, equal area is for you to draw the sides. Do you get it now? This line is what they use in drawing the side. Look at it. W, V, and Y. Let me use another color for that so you can understand. Draw the side like this, and they also draw the side like this. Do you get it now? So they draw this side and bring it to this side. They draw this side and bring it to this side. Then the next thing they did now is what? Is join the apex, which is X, U, and X, like that. So this, do you see that? This is what I just did. Good. So that is, go and check your construction of equal areas of similar shapes. Do you get it now? So they are converting, this is a conversion of a polygon to a triangle. So the answer is what? The answer is A, please. The answer is A. So the converted polygon TUWX, they converted it to a triangle of UXS triangle. So take note of that. It is conversion. So the two is going to have equal areas. The two is going to have equal area. Let's move on. 28. Radial line method is a technique to develop what? Good. So the answer is what? A cone. They ask this question almost every year. I don't know why. They ask this question almost every year. A cone. Simply, a radial line, take note, a radial line method is used for what? Is used for pyramids. Do you get it now? It's used for pyramids. And a cone is a circular pyramid. A cone is a type of pyramid. While the second one is a what? Is a parallel line method. Parallel line method is used for what? It's used for prisms. And prisms include cylinders. Cylinders are circular prisms. Do you get it now? So this we have other methods too, which is triangulation. We have triangulation, but majorly for technical drawing, Waec focuses on radial line and parallel line method. Do you get it now? So number 29. Line PQ and QR in figure 12 are two sides of a regular what? Good. Regular what? I've treated this once before. Good. So this angle you are looking outside, first thing you ask yourself, is it internal or external? Is it an internal angle or external triangle? Is an external angle. So we are giving the external angle of that polygon to be what? To be 72 degrees. So what's the formula for finding the external angle of a polygon? We are given the formula to be external angle of a polygon to be what? 360 degrees all over n. So we need to use this. So the external angle of the polygon is given as what? 72 degrees. So we are looking for the number of sides to determine which polygon. So if I multiply this like this, I will have 72 degrees n equals to what? 360 degrees n. Divide both sides by what? 72 degrees. 72 degrees. If you take away 72 from 72, 9 will go in 72 8 times. 9 will go in 36 4 0 0. Do you get it now? This will cancel each other out. The degrees, 8 here 1, 8 here 5. So n is equal to 5. So ask yourself, which polygon has 5 sides? That is what? That is pentagon. Pentagon has 5 sides. Hexagon has 6 sides. Heptagon has 7 sides. Octagon has 8 sides. What if we have 9 sides? That's nonagon. Nonagon has 9 sides. What about 10? Decagon is 10, and so on and so forth. So all these are what you should take note of. 30 now. Oh, the type of line shown in figure 13 is used to indicate dash. The type of line shown in figure 13 is used to indicate, what type of line is this? This line is called ruled line with short zigzag. My wonderful students, they will tell you this is the sign for the heartbeat. When you go to the hospital, this is the line they use for checking the heartbeat. The moment it is drawing like this, zigzag, zigzag, that means you are breathing what? You are breathing well. So anytime we are drawing this, they will tell me the heartbeat line, the heartbeat line. So they always use it to remember what we call a long break, a long break. But if your heart is having a long break, what happened? The line will become flat. That means it will become a complete straight line like this. So please, that's it. Just use it to understand the opposite part. So when your heart is breathing normal, it is this line. When it stops, it's going to cause a long break, right? Good. So this line is for the long break. For the cutting plane, if you are asked for the cutting plane is a thick, long chain like this. A thick, long chain. That is the line for cutting plane. Thick, long chain. Then hidden details is short dashes like this. Short dashes like this. Then short break. Short break is wavy line. Thin wavy line. That's a short break. Thick wavy line. That's for a short break. So the answer to this is 30. So we've come to the end of part A of section A. We've come to the end of section A. So we'll go to section B, part 1. Section B, part 1 is for building drawing. For building drawing. So is either you answer between mechanical drawing or building drawing. So let's dive into it. So 31, the two shown in figure 14 is called what? Please, very technical. This is very technical between tri-square and builder square. Tri-square and builder square. If you look at steel rule and straight edge, it's also almost the same thing. It's also almost the same thing. So they want to test your knowledge if you know the distinction between these tools. So here, the answer is what? Is B, builder square. Is builder square. If it is what? If it's a tri-square, how do you know the difference? A tri-square will show you that this top is made of steel and it will be separated. To be separated like this. Can you see the difference now? They will show it that this has a strong back, which is metal, and this has a long back. This is now. So it will be separated. It will not be full like one solid object like this. Do you get it now? So please take note. This is a builder square, not a tri-square. Let's go to question 32. The sketch in figure 15 shows a part section. Do you remember sectioning? Good. This is a part section because they didn't show us the other part of this drawing here. Of a building. Use it to answer question 32. Good. And 33. So the part labeled M, this component drawn on top of the wall is what? Is the wall plate. Drawn on top of the wall is called the wall plate. It's called the wall plate. Then number 33. We are going to use 33 to answer that drawing. Okay, the length labeled X is called what? Let's go look at it. The length labeled X. Good. The length from this point to this point. Do you see it now? That X, what is it called? Let's go look at our option. Let's go look at our option. So look at what they are talking about. Is it the rise? No. Rise is always associated with stairs. Good. Rise is always associated with stairs. Span. Span is just asking you about the length, the overall length of the drawing. Span is this place. Let me show you. They're asking you for the span. They are going to put a line across the building like this. This is what we call the span. Do you get it now? So it is not span. A lot of people argue what the answer is. If it is a rafter backing or is a backing line. The answer is a what? Is a backing line. Is a backing line. A lot of people is worried about rafter. If you look at it, this is not the rafter shown here. This is not the rafter shown here. This is the roofing sheet being used shown here, not the rafter. This is not the rafter shown here. This is the roofing sheet shown here. So that distance is called the backing line. The backing line. So we go to question 34. Yes, question 34. The type of stairs shown in figure 16 is, can you see this type of stairs? It is not half turn. If it is half turn, we will be seeing a what? A square here, like this, as the landing. Do you get it now? It's not a straight flight because it bends. Do you get it now? It's not half turn. It's not a straight flight. If it is, what confused students is because they think it turns halfway. Do you get it now? So if it turns like this, if it is half turn, you will see the landing. You know what a landing is, right? Good. The landing should be a square or a rectangle like this. Do you get it now? But since you are seeing this turning here like this, can you see that now? That is a quarter turn. So that's the difference between half turn and quarter turn. For question 35, the following symbols represent transparent material. What is the symbol for representing transparent material? It is C, please. It is C, option C. That's just the symbol we use for representing transparent material. So we'll go to 36. The type of drawing shown in figure 17 is dash. Sketch plan, floor plan, foundation plan, wall plan. What is there anything like wall plan and foundation plan? No. We can have a sketch plan, we can have a floor plan, we can have a front elevation, we can have a sectional view, we can have an end view, and so on and so forth. So the answer is between a sketch plan and a floor plan. So if you are confused, please take note of this explanation. If it is a floor plan, you are to use all the conventions, all the building conventions. For example, you should not be showing W, you should not be showing D. You should be putting the symbols to show us. Do you get it now? So this W2, W1, no. It should be the symbol with the measurement in it. That's when you give us the floor plan. But what is here is just a sketch. Do you get it now? It's just a sketch. And they are putting those letters, W1, W2, D, to tell you that this is what should be in the floor plan. So the answer here is what? Is the sketch plan. Is a sketch. Is a sketch, not a floor plan. They have not drawn it as a floor plan, just a sketch. So we'll go to number 37 under building. Figure 18 shows a building plan. Good. Can you see a building plan here now? The building plan, the floor plan here, what? It shows this conventional symbol for window, W1, W2. Can you see that now? It shows a conventional symbol for door, G. It shows a conventional symbol for wall, M. Can you see that now? It shows a conventional symbol for wardrobe, which is WR. Can you see the difference now? So they tell us that this is a building plan. We should use it to answer question 37 to 39. So let's look at the question. Which of the following building parts will not be shown in section along PP? So look at the section along PP. We have to look in what direction? We have to look in this direction. If you look in the opposite direction, please, you will not get what they're asking you. So which of the building parts will not be shown when we look at that? So are we going to see wall M? Yes, look at the wall. We are going to be seeing the wall M. Are we going to see W, window W1? Yes, we are facing it. It will face us in the elevation. We are going to be seeing it. Do you get it now? The sectional elevation is going to be, we are going to be seeing it. Then W2, the section, the cut is cutting the window. So definitely you are going to see the window in the sectioning. But dot G will not be seeing it. At the point of that dot G is the wall will be seen. Wall T will be seen. We will not see the door. So the cut takes place at that wall. So it does not get to that door. So you will not be seeing the door. G. Let's go to question 38. The convention used for representing the wall T on the section PP. Can you see it now? The convention I'm talking about. So the convention used for representing, they are asking us the convention used in representing wall. Just take note of the options. Let me go back and show you. I think I saw a door earlier on, a wall earlier on. Excellent. So look at this question. This figure 15 is showing a wall. Can you see the wall? Please, this is the wall. Let me highlight it for you. Good. This is the wall. Did you see the convention inside? That is the convention for section wall. So when we have a section wall, this is the convention for section wall. So the answer is part of the question they've given you earlier. So it's just for you to go and look at it if you've forgotten what your teacher taught you. And you see it. So the answer here will be what? Will be C. The answer here will be what? Will be C. For B is a symbol. I think that's a symbol of convention for hardcore. Convention for hardcore and all that like. So the answer is C. For 39, the specification 900 by 2100 by 40 is associated with which of the following building plan? First, ask yourself, what is the standard specification? What building member is having the standard specification? Please, is the standard specification for a door. Do you get it now? The what? The width of a door. The width of a door. That means how wide is 900. Take note of that. Then the height is what? That's the standard specification of a door. The height is always what? 2100. Do you get it now? So, and the depth, or what we call thickness, should be 40 millimeters. Do you get it now? I hope that's clear. That's 40 millimeters. Do you get it? So that should be the thickness. So you are going to ask yourself, where is the door here? Where is the door? Oh, what is the convention for door? I hope you know the convention for door. I'll circle it for you. This is the convention for door. We use the convention for door. It could be this that is being used here, or this, like this. Do you get it now? Good. So that's the convention for door. And that is G. Do you get it now? That is G. Okay, so we'll go to number 40. The type of door shown in figure 19 is, so let's look at this door. Before you even look at the option, you will see that this, let me show you, these are planks, different planks joined together like this. Do you get it now? Different planks joined together like this. Do you get it? Good. So in the olden days, there were no board. What we have is planks. So they joined them together, and they had to take another plank to join it together like this, and like this. So your teacher should have explained all this to you. So when you go to the option, you will see the words. We have flush door. Flush door should be a board, entire board, no joining. Panel door So this is simply ledged and batten, ledged and batten. So this type of door you are shown here is ledged and batten. I will explain the other types of doors. So the ledged here is those standing planks. Do you get it now? Those standing planks, those are the what? Are the batten. They are referred to as batten. Then those ones that are horizontal, do you get it now? They are the ledged. Do you get it now? So now let me explain the other types. Let me explain the other types. If it is a flush door, please watch. If it is a flush door, it should just be a board like this. Flush, no design, nothing. Nothing is being joined. It's a one complete board. If it is panel is going to be like this. It should have a design like this, like this. Do you get it now? They'll put designs inside. Most times a plank will come like, it will be in this place. A plank will be here like this. Do you get it now? So just look out for those small boxes. That is panel. If it is ledged, remember, if it is ledged, it's going to be like this. Do you get it now? It's going to be like this, ledged, and there should be bits in there like this. Then they are going to what? They are going to brace it. This is what we call a bracing. Let me use another color for that. You understand what a braced means. So when we have braced, it should go this way. Braced should go this way, like this. Do you see it now? So when you have a door like this, that's braced. You should have like that. So in coming question, they might ask you about braced. So we've come to the end of building drawing. Then we'll go to mechanical drawing. Take note, whatever is the answer in building drawing for building student should be the answer in mechanical drawing. So if you are not getting it right, you should go over again and cross check. 31, the type of sectioning in figure 20 is what? The answer is what? Is half sectioning. Half sectioning. Take note. This is P. This is now. If it is full section, it should go this way. Full section should go this way. But this is half of it. The partial section, no, it's not partial. They didn't take one part off for us to section. It's not removed. They didn't bring that section out. It's not full sectioning like I've said. Do you get it now? So take note of that. Then we'll go on 22. So let's look at 31 in building. Is it the same thing as B? 31 in building, is it the same thing as B? Can you see? Builders square. Good. So it is B. 32. The construction of gears in an application of involute A. Involute A. We use involute for the construction of gears. So don't forget that. So let's go to 32. What's the answer? Wall plate A. Can you see? It should be the same answer. Please take note of that. 33. Screw thread is designed based on the principle of the principle of what? Is it parabola? No. Involute? No. Hyperbola? No. The answer is what? The answer is ellipse. The answer is ellipse. The answer is ellipse. Please take note. That's why we said ellipse goes around a cylindrical object. So if you look at 33, we have 33 to be what? D. If you look at building drawing 33, the answer should be what? The answer should be D. Can you see? Backing line. So we'll go to number 34. 34. Good. The type of weld showed in figure 21 is what? This is fillet weld. Fillet weld. Please, mechanical students, go and revise your mechanical drawing on welding. So 35. The type of key used in the component shown in figure below is what? Gib head, saddle key, woodruff key, feather key. No, this is woodruff. Woodruff goes this way. has this, do you see it now? So it is C. That is what we fit into that place as the key. So let's go to 36 quickly. The type of pin shown in figure 23 is what? Is it taper pin? Is it split pin? Is it dowel pin? Is it cutter pin? No, this is a split pin. This is a split pin. 37. I mean, I think that's not. No, that's not a. That's a taper pin. Split pin is different from that. That's a taper. That's a. So this is a. The type of pin shown in figure. The type of pin shown in figure 23 is figure 23. This is a taper pin. This is a taper pin. A split pin and the dowel pin. No. So 37. The thread shown in figure 24 is what? Once you see those straight line, this is Acme. This is Acme thread profile. Then 38. The type of screw shown in figure 25 is what? Is a countersunk. Countersunk. The moment you see this shape anywhere, it is what? It is countersunk. It is not round. Round should look this way. Do you get it now? Good. So 39. Which of the following shows the conventional method of dimensioning a chamfered surface? A chamfered surface. Look at it. The C is the answer. Just look at the dimensioning. They're asking us what? Dimensioning of a chamfered surface. This one separates the dimension from the angle. So it is wrong. This also separates it. It is wrong. This put it on the two sides. It is wrong. It should be on only one side, and there should be multiplication telling you the 45 degrees should be at that dimension. So lastly, we have 40. The sectional view in figure 26 shows, the sectional view. So remember, we don't section a boat or a stud. So that is why that part is not sectioned. So is it a countersunk O? No. A blind O? No. If it is a blind O, please take note. If it is a blind O, it's going to form this. Do you get it now? I hope I'm drawing it correctly. So because of what I'm using, you should have, if it is a blind O, the base is going to come this way. That's a blind O. But in this case, we are having this like this. This is now. This is what? The answer is D, an external thread. An external thread. So we come to the end of answering this. So if you check, our 40 is what? Is D. Our 39 is C. Let's go to building drawing to cross check. Let's go to building drawing to cross check. 40 is what? 40 is D. Can you see? And 39 is what? 39 is C. So thank you for watching my videos. Thank you for watching my channel. We meet in another video. Have a wonderful time. Bye.